Hi, thanks for coming. You might recognize this planet. We've all spent at least a little time here. It's a pretty good one. It's my favorite so far. But we've really fucked up our geoengineering of it in the last couple hundred years, specifically people like us flying for fun, work to things like this. And our ancestors have done a real shit job of geoengineering the planet with their and our carbon emissions. So now it's time that we take things into our own hands, not magically stop flying or having other fun, but do some positive geoengineering. And we're going to need to do it ourselves, at least for a while. So like most climate things, pretty much all honest climate things, the start of this will be sad, but unlike most climate things, I promise I'm only going to depress you for the next 3 slides, and then it'll end up straight up a bit utopian / dystopian, but at least hopeful. It will be less sad than most climate presentations, and hopefully fewer numbers. So first sad slide. This is like the weirdest day I had in San Francisco. People in New York had a similar one with wildfires. There were owls hunting at noon because they thought it was the middle of the night because the sun just didn't come out that day, or did, but couldn't get through the wildfire smoke. We've deeply broken our climate with our carbon-based geoengineering for the last several hundred years. And this was one of the big things that spurred me to do this kind of sci-fi sounding thing. We've only experienced half of the warming we already have baked in. You magically disappear humanity, shut down all civilization, no more steel, no more agriculture, no more transportation, and we still get about twice as hot compared to pre-industrial levels as we have. So that's another 1.2 to 1.4 C compared to what we've already experienced in our rise since 1850. That's a lot. It's a really boring number, but it has really big consequences. Sad thing number 2, we are actively making this problem much worse. All of the green marketing is just that. It is largely green marketing. This boring graph, which I think is the only or one of 2 boring graphs in my slides, this is not cumulative. This is annual greenhouse gas emissions. We're baking in more warming every day, every year. That blip, that's COVID. That tiny blip all the way at the right. All of that reduction in transportation, blah, 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 that was that tiny blip. And again, this is annual, not cumulative greenhouse gas emissions. So we're actively making this problem worse, and that has a real cost. One of the many boringly worded papers that I've read that hides terrifying details is some scientists did us the favor of calculating the mortality cost of carbon. The emissions of 2.3 average Americans results in an incremental heat-related death that otherwise would not have occurred between now and 2100. So because of, I've got 4 siblings and my mom, our family means 2 extra people die who wouldn't have otherwise between now and 2100, just from, this isn't like downstream political upheaval, this is the direct temperature consequences of the carbon we're emitting. So, we're not pulling the trigger, but we are taking the flights. And we're not going to stop. Last one, I promise. Just hang through this last depressing thing, and then it'll get at least hopeful. None of our carbon tech works at scale, and it might never. Most voluntary carbon credits, NPR and the Guardian's number is 90% of the accredited voluntary carbon credits, like when you book a flight and you can click to pay $1 to plant a tree, 90% of them are imaginary, meaning the tree is never planted. The same tree is planted every year and then dies. And they're claiming the credit of this tree existing for 80 years and never being harvested. So most of those are fake. This is a fun game. It's not up anymore. This used to be CDR.FYI, but you can still see it on the Wayback Machine. You pick different strategies among all these buzzy things that oil companies are marketing to us. Like, oh, we can do blue carbon, we can do like kelp and sink it, or we can do soil-based sequestration, or bioenergy capture and storage, or direct air capture at $600 per ton note, or we can just plant more trees. And then it's fun because it shows you the deal breakers as you violate the laws of physics or economics with your strategies. So like with this one, and this is only to 14.4 billion tons. This is like a fifth or less of what we actually need to be net zero to start stopping making the problem worse, to be clear. Net zero means we're just not making it worse. We still have all the carbon we emitted. So yeah, Everybody good on the sad news? Yeah, it's a lot, and it's very rational, probably more rational than anything else to be a climate doomer or to just fucking ignore it and like go play video games or something. And yeah, I was feeling pretty depressed reading this a couple years ago. Like I could use a strong drink or five. And yeah, it makes a lot of sense to just think that the world is deeply fucked and there's nothing we can do about it. The world is obviously deeply fucked, but there are many things we can do about it. One of the fun things I tried was protest. This is me in downtown Manhattan several years ago with Extinction Rebellion, getting arrested for meditating in the middle of the street on Black Friday. It was a lot of fun. Surprisingly, we didn't suddenly overthrow industrial civilization, but highly recommend it. It's a lot of fun, particularly with friends. That didn't work. Tried starting a farm. That didn't really work. So I kind of gave up. I moved to Mexico and started spearfishing for hours a day in Baja, built a little solar and battery powered trailer. And I was, a while away my days. I'll write about what I'm doing a little bit for like the 3 other people in the world who care about putting solar panels on an RV in Baja. And yeah, I just kind of, watch the world burn and do my personal part to document the tiny, tiny bit that I'm doing while still flying too much. But then I made a mistake. Never read books. Sometimes they'll make you want to build the things they talk about. Specifically, this is Neil Stephenson's most recent, and it introduced me to this idea of solar geoengineering, that we can put reflective clouds or something else high into the sky or even into space to cool Earth by reflecting a little bit of sunlight. So I finished the book. I was like, fuck, I'm going to really have to dig into this. This is like too interesting not to learn more about. And I became more than a little obsessed. I learned about Mount Pinatubo, which you can see erupting here. This one eruption, one volcano, made enough high altitude sulfur dioxide that it cooled the Earth by 0.5 degree for 2 years from this one eruption. I also learned that there's really strong consensus among scientists. Unlike many other things like marine cloud brightening, most of the things in climate tech that are newer, this is pretty much the consensus view. Solar geoengineering could offset most climate change for most people most of the time. As scientists tend to have, this is a very dry way of saying something really important. We can do something about at least the temperature part of this problem. And one of the craziest things I learned was that nobody had done this. So to back up a little bit, by this, I mean solar radiation management. If during our life we want the world to be cooler, we need to slightly reduce the amount of sun that hits the planet. There's one thing not on this chart. The most likely option is nuclear war, which would also reduce the amount of sun that hits the planet. What I'm doing is a little controversial, as are these other things. I think everyone can agree that they're at least slightly better than nuclear war. So in short, this basically goes from best idea to worst idea, top to bottom. Magic mirrors in space. If you are Jeff Bezos or richer, you should put magic mirrors in space. That's better than what I'm doing or anything anyone else says in climate tech at all, except for the whole needing to put magic mirrors in space. But when we get our act together somewhere between now and building a Dyson sphere, we'll obviously do that. We'll have tunable mirrors in space, probably at the Lagrange point, reflect back some sunlight, regulate our temperature, take our couple hundred years to decarbonize. Second is what I do, stratospheric aerosol injection. This is putting lightweight reflective particles high up in the sky and the stratosphere so that they stay up for a long time. That reflects some sunlight before it gets to the lowest layer of the atmosphere called the troposphere. Cirrus cloud thinning, marine cloud brightening, basically I put in this category of fuck with clouds that like cloud scientists will be the first to tell you we don't understand that much about clouds. This is like, as utopian startup tech bro guy, I won't touch these because we don't know directionality. That's my standard and what I'd suggest for anyone else who wants to like startup-ize something. We need to know what direction number go. With marine cloud brightening, the consensus is that if you get the particle size wrong, like, if you're spraying over the Great Barrier Reef, like Australia is doing right now, your particles get a little too big, you're spraying salt water, which like breaks everything, then you may create net warming globally rather than net cooling. If water particles are above a certain size, they absorb more energy than they reflect. So I won't touch those things. If people figure that out, that's cool. We can add it. Others can add it to the mix at some point. So I read a bunch of this, talked to some of the scientists involved, and couldn't stop thinking about it. Couldn't figure out like why nobody had done this. So spent about $300 on Amazon, found a tank of helium in Baja, which was probably the hardest part. Bought some sulfur, which I burnt, coughed a bunch because I was breathing sulfur dioxide, which precipitates to sulfuric acid in your lungs, and captured a little bit of it in the balloon, added a zip tie, told it shut after putting in some helium. No telemetry, nothing, let it go. I was like, that was kind of fun. Balloons are cool. Bigger balloons are cooler. And if you were in the stratosphere or near the stratosphere, because I can't confirm that it actually got there, on that day over La Ventana and Baja, when the balloon got to the top, you'd see something like this. So this is not sulfur dioxide. I should have told you that first. I gotta read my own notes. This is literally calcium carbonate. It's chalk dust, literally edible, very dry. Tums, I think, are made out of it. But this is another substance that people use. It's not as effective per unit weight and per amount of ozone degradation. So it was like popular in the literature for a while, then people stopped talking about it. We do this for giveaways. Like after this, come grab a balloon, put some chalk dust in it and add some helium. And if you accidentally let it go outside, then you too will become, in a small way, a geoengineer. But yeah, that's basically what we do. Better helium, much bigger balloons, some tracking on it, and sulfur dioxide, which we now get as a gas and no longer breathing tons of sulfuric acid. Yeah, that's what happens. The balloons, everybody asks this for some reason. The balloons are latex, so they biodegrade after 2 to 3 years. And if this was outside, the world would be the tiniest bit cooler. Startup tech bro, so eventually convinced a friend to join me trying to turn this into a company. We made up something called cooling credits. They're not carbon credits because all we're doing is dealing with temperature, not the carbon element. And 1 cooling credit equals us putting up enough sulfur dioxide to offset the warming effect of 1 ton of CO2 for 1 year. The time stuff's weird. CO2 stays up there largely for hundreds of years. Our particle stays up for 2 to 3. So we just talk about ton years. If you dig deeper in the literature for other things, you'll figure out that people usually, like the tree planting guys, pretend they're going to grow the tree for like 80 years. They talk about like GWP 80, bunch of boring science stuff. But point is, they can go up, make worlds slightly cooler in a very specific, quantifiable way. Yeah, making the sulfur dioxide ourselves was rough. This is in a hotel room in Reno. It was like very much like Breaking Bad. This is an induction burner because I wanted to be safe and not just have an open flame in the hotel room. And I was trying to vacuum pump most of the fumes of the burning sulfur, which sulfur combusts to sulfur dioxide, capture them in here without like choking everyone in the room from the sulfur dioxide precipitating sulfuric acid in their lungs, and then run it through a dry ice chamber to try to precipitate out the sulfur dioxide. And it didn't work well. And I was like, I don't need to actually do everything myself. Turns out sulfur dioxide is something you just buy by the tank. It's quite cheap. My helium's actually way more expensive than it is. So yeah, it's much more boring now. Now we just put in 1 gas, add another gas. We've moved on to bigger balloons. This has like 600 grams of sulfur dioxide in it. Ours are now like 3 times as big. And yeah, this is at a launch in Reno. This is what it actually looks like when one of our clouds pop. One of our balloons pop, releasing clouds. That's the curvature of the Earth. We're well into the stratosphere here. My high-tech buoyancy, a chunk of styrofoam. And then parachute opening very slowly because there's very thin up there. And it returns to Earth. Sometimes we even find where it landed. So look, confession time. This is fun. We raised some money to do it. Clearly I like talking about it. Clearly it's like controversial and that's kind of fun. But we're the slightest whiff of a drop in the bucket. We make about 1/3 what we spend, which we're thrilled by. And that's mainly because we work out of an RV, so we don't really spend very much. But we need a lot more people doing this, and we need them to do a much better job at it than we are, whether it's, as a startup, for fun, as a nonprofit, I don't know. However people want to do it, more people should do it. So we've started giving away a good number of balloons at Earth Day in San Francisco year before we did. I went to India and spoke and gave some of the kids to release. Everybody loves balloons. It's one thing that I've definitively figured out in several years. It took me to figure that out. Yeah, so afterwards, definitely come grab a balloon, put in some calcium carbonate, add some helium, accidentally let it go outside. Technically, I have to report that to NOAA, even for these balloons. The reporting requirement, one of the two agencies regulate this. FAA, I have to tell them when I'm launching something and roughly where. And then NOAA, this is a weather modification activity. So if you think you're changing the weather, you have to tell NOAA. It doesn't matter whether it works or not. So technically, if you're casting a spell that you think will change the weather, you have to report to NOAA. But giant chemical plants that emit like megatons of the same chemical don't have to report because their intent isn't to change the weather. One of the many silly details of this. So what if you actually want to offset your full warming? And again, it's only warming, not all the other problems with carbon and pollution, blah, blah, blah. But if you just want to focus on your warming impact, what do you actually have to do to offset that? This is the key number. And this is about radiative forcing, how much in watts per square meter we affect energy on the Earth. So 1 gram of sulfur dioxide, the chemical we use, roughly offsets the warming impact of 1 ton of CO2 for 1 year. And this assumes we deliver it all the way to the stratosphere. There's uncertainty with both of these, both CO2's warming impact and SO2's cooling impact. But, just like with CO2, we shouldn't let uncertainty, when we know directionality, prevent us from taking action. So if I want to offset my personal warming impact this year, I got to handle the CO2 I emitted this year. And because our particles only we match it to a ton year, I have to deal with all the shit from the past 41 years of my life that's still up there. So the new stuff's easy. You're about 20 tons per year, give or take a little bit. You can do a carbon calculator if you want to nerd out on it. You'll be within 30% of that, almost definitely. If you want to be fancy, make it 30 tons, and you'll almost definitely be covering more than you're emitting then. So that's easy. That's 20 grams of SO2. This is like a kilogram. So it's like way less than that. My very technical explanation. So that's easy. Where it gets gnarly is when you look at historical emissions for, yourself or Western civilization or the planet as a whole. That's why a number go up in terms of temperature and in terms of CO2 level. For the first 11 years of my life, that total impact in warming ton years of CO2 is already 7,900 ton years. So that's, quite a bit more to offset. If you expand this out, 41 years of CO2 has produced, of my CO2 emissions at 20 roughly tons per year, has already produced 17,000 ton years worth of warming. You start to see why this is like, people's emissions add up with this gas that stays there for hundreds of years. So let's assume I live to 100 and emit about the same. That'd be about 101,000 ton years. The asterisk is that's just during my life, because that shit is still going to stay up there for hundreds of years more. But I promise no more depressing, so we won't dive into that too much. I'd be happy to offset that for you, but it's like kind of ridiculously expensive. We charge between $1 and $10 per gram of SO2, which offsets a ton year. So that'd be about $101,000. You should not pay me to do that unless you are or know like a Jeff Bezos or two. They should. Instead, you should do it yourself. It is a perfect hacker problem. There's nothing you need to do to get it to work in the right direction. Even if these pop before they reach the stratosphere, by the way, they still create a slight amount of coolant. You might have seen some article about ship emissions being reduced because they made them use cleaner fuel. That actually made the world, it was good because this is nasty if you emit it at the surface. That actually made the world a little bit warmer though, from that reduction in sulfur in the fuel. So this is what it looks like for us with our big balloons now. Our big balloons are 1,500 grams. Most of our cost is helium, then the balloon, then the SO2, and then the telemetry. And not only are these interesting things for me and for this project, and I want you to work on it because it'll make my life easier and help save the world from being far too hot. But they're also all cool categories of things that there are tons of opportunities to do other cool hacker style shit with. So we'll descend from biggest chunk of cost to cool planet. Biggest and most sketchy, if you ask a physicist, is our use of helium. So lift gas is what we need. We need something lighter than air or some super crazy big plane, but that's too complicated for me anytime soon to get up to where the air is so thin in the stratosphere. At any point on Earth, it's less than or equal to 20 kilometers up. That we just simplified and used. Did our balloon get to 20 kilometers? If yes, credits count as delivered to customers. If no, launch another balloon. This is me starting to experiment with making our own hydrogen. And this is filling directly into the balloon because I don't want to be compressing hydrogen. Yeah, no, one of them exploded as in pop, but didn't explode as in fire. I think hydrogen gets an unnecessarily bad rap. And if I'm not here with burns all over my body next year, then, you know. And there's all this weird, like, subsidized stuff that happened with hydrogen that I don't understand because politics, but this is a Toyota Mirai. That fuel cell I can't find for sale anywhere for like less than $50,000+. Even then I can't. They're all bigger and like hundreds of thousands of dollars. But these cars are only useful if you live very close to the hydrogen refilling stations. I think there's like 3 on the East Coast and maybe 10 on the West Coast. You have to live and only drive within 150 mile range of there. So everybody sells them for super cheap all the time. They have a fuel cell, they have batteries, they have all kind of cool stuff in them. I haven't seen like a good proper teardown, but like you could certainly play with that. 1, for fun. 2, for like a renewables strategy that actually meaningfully, unlike any small scale ones I've seen, incorporates storage with something other than super expensive batteries with limited capacity. Like make hydrogen with an electrolyzer from the battery, then run it through this fuel cell. I don't know. You guys can figure it out. And you get oxygen, which you can get like kind of stoned on as a side effect too. So all kind of potential there. Next, the balloon. You can make your own. Everybody loves balloons. Even during that Chinese balloon, blah, 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 nobody even took it seriously because it's balloons. They're just super fun. This is one that Project Loon made. Google cut that for a variety of reasons, according to people that work there. But the people who work there were able to get them to open source almost all of their stuff. So you can find this huge technical library, even including like readings from their instrumentation in the stratosphere that you can build off of. The company that still makes these won't sell them to anyone. It's called Raid and Aerostar. And if this looks like just a giant plastic bag like you put a sandwich in, you're right. It's a slightly different secretive blend of polyethylene and something else, but polyethylene is that exact same plastic, which you can literally buy rolls of and heat together with a heat sealer of a specific temperature that you can play with. It's 48-inch by 450-foot roll, so like we haven't got around to making them ourselves yet, but you can literally make these. You can be the one to resurrect the Hindenburg and make a full Cory Doctorow walk-away blimp-style future. It gets a bad rap. You guys will figure it out. It'll work. You should technically flare the hydrogen rather than letting it out. You should burn the plastic if you're doing what we are. These biodegrade, polyethylene doesn't, so like just burn it up there. It'll be fine. Next, sulfur, 6th most abundant element. Ironically, pure sulfur is a byproduct of oil and gas refining. You can just burn it to make sulfur dioxide. If you do that in the stratosphere, move sulfur only and then burn with, accounting for the thinness of the air, blah, 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 then your weight's about half. Oxygen weighs half as much as sulfur. So SO2, you're only moving half as much weight. That'd be great. Make it twice as efficient. Or do some crazy diamond age style stuff. This is a pile of titanium dioxide. People have talked about that. They've talked about diamonds. There's all kind of, anytime you hear new nanomaterial, if it's basically what you want is something that's as lightweight, as cheap, as non-reactive, and as reflective as possible. And that's like, those are the only criteria. Everybody's gonna bitch at you. I'll tell you, like all the scientists will bitch at you regardless of what you put up. We're putting up literally the same chemicals as volcanoes, and everybody complains about us. So like, put up whatever you want. Nobody cares. There's like basically no rules up there. Actually, literally, the summary someone at Loom told me was that, you have to like, if you go above a certain size, the FAA makes you put like a little streamer and red blinky light on your balloon. But other than that, you just have to tell them when you're launching. And then when you get to the stratosphere, how do you put it? The only other people up there are military. They like to pretend that they're not there anyways. So you can just basically do whatever you want and they'll work around you. So it's like a perfect blank slate to explore. This is a Spot Trace. It's a $100 GPS with a satellite link that costs $10 a month with satellite link. We launch them all the time. They're kind of our bread and butter sensor. they cut out and we have to infer based on when they re-enter because what is it? It's like some export regulation. You're not supposed to be able to have a GPS. It's unclear how the defense, like the defense arm, whatever the arms thing is called, it was written ambiguously about whether your GPS had to cut out above a certain altitude and above a certain speed or above a certain altitude or speed. So like, of course, all the Chinese OEMs were like, we'll interpret this in the cheapest way possible. So most of the direct from China ones, obviously I've already figured out you can get to work at a high altitude. So you could like improve these, make a good one. There's some like ham radio ones. They're super complicated. I lose them all the time. Or, get really fancy and like take a hobbyist RC plane. They're like quadcopters, but way more crashable and they're made of foams. They fall apart all the time. Get it to fly back to you when the balloon pops, taking video the whole time. Do not use it to deliver weapons or drugs, or don't tell me about it if you do and just print money. So what we get to skip is all the boring modeling. Scientists have modeled this shit to death. They even made a little tool where you can play with it, planetparasol.ai. You can choose your different injection strategy. And this is the second, this is like a hopeful chart, not a boring, it's a boring hopeful chart, not a boring depressing one. All of these environmental charts, and you'll notice pretty much all of them at 2100. Like, isn't that weird? Maybe we solved the problem. No, it's just the number keeps getting worse. So people just like cut it off at 2100, just like for fun. And then all of the small print, like, oh, this is like a nice pink. Can't be that bad, right? Drastic loss of habitable land and mass displacement. Global food systems collapse, leading to famine. This line, no stratospheric aerosol injection. This line, about 25 million tons of sulfur dioxide per year. Not perfect, but yellow, hella better than pink area. And a lot of these, like we regularly break climate records, you might have noticed. Forecasts tend to be conservative, and then we like notice that massive regions of forest are on fire and we're breaking the records most of the time. So, I hope they're right that this is worse, but I wouldn't rule out this even nastier shit. So yeah, we literally know what this will do. We're just not doing it. And, in case you needed a reminder, these are the adults in the room. So clearly we cannot rely on anyone else to do this for us. This is a hacker problem because, whether we figure it out or not, we can either one, keep our heads in the sand, and then this is where we end up by transforming our planet into it. Or we can, kind of take responsibility for holistically managing all layers of our atmosphere and the environment overall. Realize that technology is largely what got us into this problem and what's going to let us muddle through as it always does. And really, take ownership and get here as in go to actual Mars and become the interplanetary civilization that we already should have by holistically managing our atmosphere, getting way better at it. And yeah, I prefer to go there, not to turn here into there. So let's get to work. Cooling Earth is one of the more ambitious DIY projects, but it's a perfect hacker project. This is not rocket science. It's balloon play hack time. And we don't really have any other choice. It's our one planet so far. So let's get to work hacking the planet. We have a ton of time for questions. Please come up and take balloons. Thank you.
Just next all of you. So you mentioned having a holistic approach to geoengineering. I'm wondering how you calculate assumed risk, because it's my understanding that unless that is organic latex, if it mixed with any synthetic materials, it's not biodegradable. And even in the time that it takes to biodegrade, I'm wondering what you consider it's okay if it's ingested by animals.
So our balloons these ones have like, whatever on them, but they're super tiny. So I don't really worry about them, to be honest. Our big ones are pure latex. This is, I think, a great example of needing broadly on the left in environmentalism, et cetera, to zoom out and not focus on only doing perfect things while the right burns the world to the ground. Like, yes, I should look into that, but no, it shouldn't be it shouldn't it shouldn't paralyze us from doing something like 1.5 kilogram balloon creates 1,500 ton years of cooling, which is like more than most of the giant carbon capture plants do. Different because they're longer term. But yeah, I will look into that and make sure that they're pure. And yeah, broadly, I want us to experiment more.
I like the exercise here because it's wondering how what we can do as individuals or as communities to solve these issues using the hacker mindset. Broadly, there are many reasons why geoengineering hasn't been tried. On a macro level, I mean, geopolitically, it's quite risky. The Earth is a very complex system. We don't know enough about it, and we don't know how it's gonna chemically affect, say, the ozone layer. We don't know what kind of effects it will have on weather systems, which many countries depend on for food. So there's all that. So while I like the exercise, I don't quite agree with the final solution in regards to geoengineering, especially since the critique here is business as usual, and geoengineering will be eventually used by the Western countries will realize that it's a bigger risk having temperature rise. They will implement geoengineering, whether it affects the global south or not, and it will allow business as usual, which is what we don't want. The problem is business as usual. So I like that because in that there will be a space for geoengineering to mitigate, right? But we need a vision of how we can change from business as usual to sustainable path, way to live, right? So there's some literature that I'd like to share. Termination shock is interesting, though there's also the fact that termination shock, the concept of, well, once we stop putting aerosols in the air, well, all that CO2 is going to have an effect immediately, and no one knows how bad that is, except it's bad. And then there's also the fact there's Neil Stephenson's book, Ministry of the Future, which explores engineering. More of a politically I'm less down with that book, but it's interesting. And then there's Half Earth Socialism, which tries to explore utopia of how we can change our energy systems for that balance. And I think the first chapter to explore geoengineering, how it's actually playing into the green capitalism like philosophy. And so there's that. So to finish with the question, since it's the comment, and are there any other hacker solutions, like using that mindset to try to solve these problems, which are political problems, by the way, that you have explored, seen in other communities? I'm curious if you have other examples.
I'll check out how socialism. I hadn't heard about that. Thanks. Are there other? Yeah, I think the normal thing is like Kim Stanley Robinson, personal style, or like me moving to Mexico to be like, fuck this, like have some privilege from tech, blah, 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 and go live in the woods with your off-grid system. It's nice. I don't think it's particularly morally admirable unless you're like cranking out KSR level novels. Business as usual is people die because of the flights that we took here. It's specifically calculated that's like a lower bound. Like our carbon footprint, you and me, means another person dies between now from temperature and 2100 who wouldn't. So we're essentially killing people while we talk and debate some future ideal state, which I agree we should work for. But in the meantime, people are dying, and we personally can do something about it that like we might actually do, because we're not, unfortunately, in my personal opinion, overthrowing capitalism tomorrow. In the meantime, we need to do this because, again, it's not pristine nature is the status quo. Pristine nature is the world is on fire because of our geoengineering via our carbon emissions. So yeah, I agree. This is a temporary solution. It doesn't solve carbon emissions. It doesn't solve egalitarianism. There's a lot more we need to do. This is one of the many things that, in my opinion, we should.
Hi. I'm often hung up on perfect versus enemy of the perfect is the enemy of the good. It tends to hold me back from things. But just thinking about how good this solution is, one of the things I see a lot when looking at, enhanced weathering of the salt or carbon sequestration by like biomass sequestration and stuff, is a lot of the costs are kind of ignored. But I didn't see you talk at all about like what is the cost of actually getting this carbon, getting this latex, getting the sulfur, and specifically you talked about losing a lot of like electrolytes. How do you calculate those costs? Do you calculate those costs?
Yeah, so right now we sell our cooling credits for between $1 and $10. It costs us 20 to 30 cents for my own hydrogen versus buying helium. At scale, like stepping back fundamentals, the hard costs are next to nothing. They're so low that the lead researcher on geoengineering, who also started a direct air capture company and sold it to an oil company because they're the only people excited about it, because they can pump it into mines to get more oil out. Literally, that's what they use a substantial amount of the CO2 for. He is opposed to any commercialization of geoengineering, of stratospheric aerosol injection, because it's fundamentally so cheap at scale that he thinks it will break the carbon markets or lead to runaway cooling, which is a theory. I mean, sulfur, the cost per ton of sulfur, and again, a gram offsets the warming of a ton of CO2 for a year. Cost per ton of sulfur in bulk is roughly $200. So it costs basically nothing. Getting it up there is the hard part. Most researchers say that like step one should be a $20 billion 10-year program to build high altitude capable aircraft that can deploy huge amounts at once. And like, yeah, that'd be cool, but while we're in fantasy land, let's build space mirrors, right? For like MVP, like thing we can do now in small quantities with huge inefficiencies around the electronics, blah, 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 but learning as we go and getting to play with balloons. Balloons are the way to go. For now.
This discussion sort of reminds me of the last season of The Good Place, where every time you think you're doing something good, you may be causing harm. I don't think we should demonize any groups, yourself included, but going back, the streets were rivers of shit, pardon my language, from the horses, and people thought the internal combustion engine was going to cure that. And now, you might want to talk to the environmental group Oceana. They're celebrating, for instance, the new law in Florida that makes releasing balloons illegal. So balloons rank among the deadliest ocean plastic for key wildlife and the deadliest form of plastic debris for seabirds. Florida's new law will help save ocean animals from these preventable deaths, said Hunter Miller, Florida representative of the Washington-based environmental group Oceana. So in Florida, they made it illegal for anyone to release a balloon that's over the age of 7. And in the state of New York,
What about mentally under the age of 7?
The state of New York also now has legislation that says no person will knowingly release or intentionally cause to be released outdoors a balloon, and a balloon shall refer to a flexible, non-porous bag made of materials such as rubber, latex, polypropylene, or that contains helium, hydrogen, air, oxygen, and air, water. So there's a concern about balloons. Now, what my question is, what's the trade-off? How many birds or fish should be harmed? Have you studied the science of how much you're going to cool the earth? I mean, because back when they invented, the engines, they told everybody, bury your oil in the yard in rocks because that's okay. And it took a while to learn that wasn't. So how much, is maybe balloons the right thing to do right now, or should we study it a little more and figure out maybe a better delivery method? That's very honest question.
Yeah. I mean, I encourage people not to trust me on the cost benefits. Obviously, I'm a bit biased. But yeah, I think if you dig into the literature yourself, you'll likely reach a similar conclusion. Make sure, this confused me for a long time, make sure when you look at the downsides that you look at the scope, because often people will, if someone's mentioning things like stratospheric heating, they're talking about offsetting all man-made warming and assuming it increases and offsetting that too, and only using sulfur dioxide, and they're at like 50 megatons a year, which is obviously stupid. It's like, don't do this thing at a small scale unless you can deal with the consequences of only doing this everywhere all the time.
And by the way, I'm not saying, I'm not in a good place here. So I have no idea. I'm just sort of trying to understand. I have no idea how many fish, like I think this, the idea of plastic straws being illegal, how many fish are you saving? How many balloons is really going to harm a fish or a bird or our environment? Although now people are talking about microplastics in all of us, in our blood, even in places where they don't even know why. And so how many degrees will this effort help versus how much, what will this do to our lifespans?
Yeah, I think that balancing those in all of our decisions is important. There are no good options here, to be blunt. Like, if you find them, let me know. And yeah, but I think continuing past that with all of our trade-offs, like I, like Stuart Brand, opposed, genetic engineering and nuclear, but then data. So I don't anymore because, cost benefit analysis.
Thank you for your presentation. I've really enjoyed it. You were talking about how there are multiple different kinds of aerosols that can be put up there, and I'd just like to hear a little more about some of the differences. Obviously, sulfur dioxide can become sulfuric acid. The calcium carbonate you have on the table there is obviously less reactive in that way, but it also has problems. And titanium dioxide is famously reflective. Some other information about other compounds and their gives and takes.
Yeah, a big part of why I did this was to do it because no one else had, in spite of like the adults in the room that you would want. Like a Gates-funded Harvard project called ScopeX started researching this 15 years ago. They were going to do an instrumentation-only flight. It got canceled because political opposition. Their future plan after that flight with like 500 kilograms of instrumentation was to release this size of chalk dust, the same chemical. They were going to release 1 kilogram of it and then study, in my opinion, to death, exactly how the aerosols propagated. So like 30 people could write PhDs about the aerosol physics of that, which is cool, but again, should not, in my opinion, be a barrier to action. So long answer short, we can and should research the many other things we might use up there. If you want to dig into the stratosphere, like there's very little known about it. The tagline that the few people who try to explore it will tell you is that we know more about the bottom of the ocean than the stratosphere. Like it's actively debated whether there's biological life there at all. A couple sampling balloons came back with life on them, and it's unclear if they were contaminated or if there are microbes up there, which would change like dramatically the number of organisms on the planet overall. So like we need way more exploration of all of this.
So sulfur dioxide, I looked it up because to know more about it, and apparently it's the biggest chemical responsible for acid rain, and the increased amount of sulfur dioxide in the rain has caused multiple species. We were mentioning fish before, have caused multiple species of fish to go extinct. So why sulfur dioxide when that's known to hurt the environment more? By being in the atmosphere, by causing rain, and when you have a cooling effect, it causes precipitation, which causes the rain to form. So basically, you're exceeding acid rain more than anything. So why go with that choice?
Yeah, so I don't know the details of the science, but even strong critics of this will tell you that if we do 1.5x Mount Pinatubo, like in the keep us out of nasty pink zone graph, if we do that per year, there is no meaningful increase in acid rain. Something to do with it being in the stratosphere.
That's the thing. You're releasing concentrated, not spread out over like a huge area.
Yeah, so we're releasing it as an aerosol. So a pro and a con of it is that it rapidly propagates very far. We get the importance of getting to the stratosphere is so that we enter the Brewer-Dobbs circulation. The particles technically settle out near the poles after a couple of years, and we want to launch like 35 degrees or closer to the equator. At large scale, it'll matter. Like you need like 6 to 8 launch sites, some of them north, some of them south, and then we'll learn as we go like exactly how to regulate quantities of those at the megaton scale.
So why that one? Like why not something that's more neutral that doesn't cause acid rain, and it's hopefully cheaper too?
Yeah, so people were really excited about calcium carbonate. then a bunch of PhDs did a bunch of modeling on it, and it is substantially.
But this one we know is bad. Like that's the thing. Like this is already known to cause issues. So
Yeah, so it's all about quantity. For example, the quantity that we took out of ship fuel when the International Maritime Organization, like 3 years ago, made ships burn less sulfur. If we instead,
you always increase the quantity of it.
so ships were made to reduce it. And if we take that quantity, the ships are no longer emitting.
Yeah, but we
And
don't have
instead-
acid right now because the quantity dropped.
Sorry, let me finish. If instead we put that quantity into the stratosphere rather than emitting it from smokestacks, this is 21x roughly more effective in the stratosphere per unit emission. So that quantity, if we move that there, 21x more effective, we actually don't know. That would be way over the 1.5x Pinatubo. We know we would cool the world by at least 3/4 of a degree Celsius. If yearly, we took that amount of sulfur dioxide and instead put it in the stratosphere. And I can't speak in detail to how many species have become extinct, if any, from acid rain, but I can tell you that many more will be saved if we drop global temperatures by 3/4 of a degree Celsius, including, millions of people.
I'm just saying the if any part kind of speaks a lot because we know like it damages species like this.
Thanks for bringing this wacky idea to this conference.
I try.
We need vision right now. I mean, it's late. It is late. That graph you showed, it's late. We could be fucked. I don't know. I'm not a scientist, whatever. Anyway, thanks for your sacrifice in XR. I too got arrested 3 times. I don't know if we moved the fucking needle or not. Maybe we did. Is there a direct action component to this balloon thing? It's a provocative idea. It's like, we're release balloons. It's like, that's not going to work. But it's provocative. I think it could capture the imagination. I know that's overused, but is there a way? I don't know.
I hope so.
Yeah, do it yourself, but anything worth doing is worth doing with others. I'm always leaning toward that. It can be a mass movement. Have you thought about it?
Yeah, I mean, like, I'm a startup guy, so everything looks like a startup. I don't think it's the only form of change. I don't think it's a particularly fun one. I don't agree philosophically with the privatization of most things, let alone our troposphere, let alone our stratosphere. Like you said, it's late stage. And also, like, I should have stressed this, like, whatever we're doing, we have to have some fucking fun doing it, because most activists or people trying to change anything, or who even just like pay any attention to anything with climate, are pretty fucking depressed. And it's understandable because it's pretty fucking depressing. So like, agree with me or not, but please agree with me that you will take an approach where, like, as the world continues to burn, you try to put out the fire, but you also do it like in a radically fun way, because otherwise you'll burn out and you'll be one of the many, many, many smart people burnt out on trying to change anything, because it's hard work and it's depressing. So figure out, like, whatever that is for you, a fun way to do it, including like opposing this. I hope someone opposes this. Like, scientists who bitch about it, I tell them in their research funding request, please mention us as an example of what happens if we don't fund adults properly researching. Like, and I hope they do. And frankly, like, to stop this, I mean, partially by luck, partially by design, we have to have autonomous boats electrolyzing filtered seawater with solar power and launching balloons from recycled ocean plastic. If there's demand, we'll do that. And that's pretty hard, if not impossible, to shut down without having an internationally robust system that manages all layers of our atmosphere. So if that's what we end up with, I'm very happy with that failure. End of atmosphere regulation rant.
That would be shooting for the moon and landing in the stars type thing. I'm okay with that too. Can't run a revolution on hopelessness. Really appreciate, even if everyone here doesn't agree on the approach, I think it's clear that something has to be done. We talk about geoengineering as though it's something that's not already been happening for hundreds of years, but we, through human, like anthropogenic, and what human-driven climate change is like the story of our lives. And again, as we all know, it's not going to change anytime soon. I don't think perfect can be the enemy of the good. And again, there's plenty of valid critiques of what we've seen here today. But I think, it's not ethically defensible to sit on our hands and not do anything. So props to you for bringing this to us. I got a lot of strong feelings about injecting sulfur dioxide into the atmosphere, like lots of bad things that can happen with that. But regardless, there are a lot of different approaches. And I wonder if you've seen anything around like obfuscation of sunlight reaching the surface of the earth and the potential impact on crop yields of that, obviously that, you know, crops are going to fail as the atmosphere heats up and the planet heats up and everything like that. But, you know, even if we filter out 10% of the light that reaches the surface of the earth, or some percent, I don't know if there's been any research into that.
Yeah, there has. This is one of the weirder results. On average, plants photosynthesize a little more under diffuse rather than point sources of light. So if we do 1.5x Pinatubos annually, there'll be, I think it's a 2 to 3% net global increase in photosynthesis. So things are so fucked up that one way that this might actually end up being a business is somebody just does it at scale and then claims those, if carbon credits ever become a meaningful thing and not just voluntary in most places, if someone can claim the credit for that 3% global increase in photosynthesis and the carbon sequestration impact of that, that might be like the weird little detail that somehow monetizes it. Thanks. Thanks.